So up to last lecture we are studied about the acceleration part. Okay, simply acceleration is what? Change in velocity with respect to time is simply called as a acceleration. Okay, also we studied uniform motion and non-uniform motion. In that we studied if equal distances cover in equal time interval, then such a motion are called as a uniform motion. And if unequal distances covered in equal interval of time, then such motions are called as a non-uniform motion. That definitions and how this case happen, that we studied with the example in the last lecture. Okay, also we studied the acceleration part, type of acceleration, positive acceleration, negative acceleration and zero acceleration. Their definition: positive means what? Simply velocity continuously increasing, then acceleration produced is called positive acceleration. If velocity decreases with respect to time, then acceleration is negative. Okay, and zero acceleration means what? If velocity of an object remain constant throughout motion, okay, then that time no velocity change is takes place there. That is why that acceleration is called as a zero acceleration. That much part we have to study up to last lecture. Okay, now here today's lecture we have to see distance time graph for uniform motion. Okay, what? Distance time graph. I think you are all students know about the graph. Okay, in graph you are, I think, already studied graph what in mathematics for the representation of histogram, pie chart. Okay, so there we use graph. Okay, so graph means what? Whatever the data we have to make picture of that graph. Pictorial representation of data is simply called as a graph, and that graph we have to draw now. What graph? Distance time graph. We have to use two things. One is distance and second is time. Okay, in what? For what? Uniform motion. Motion is how much? Uniform. Uniform means what here? Equal distance will cover in equal interval of time. Look at that given data here. Okay, initially our time is 0, then our distance is also 0. Okay, then after 10 seconds our distance is 15 meters. After 20 seconds our distance is 30 meter. After 30 seconds our distance is 45 meter. Similarly, after 60 seconds our distance is 90 meter. In each interval of time our distance changes by 15 meter. For equal interval of time our distance also equal change. Okay, so such a motion are called as a uniform motion. For this motion we have to graph this graph. For this motion, for this data we have to draw a graph. Okay, so first of all, directly go in drawing to the graph. I will tell you some important thing that also you have to remember when you draw a graph. Okay, first of all, we know in the graph there are in two dimension. Okay, x axis and y axis. There are two lines. One is horizontal line and one is vertical line. Okay, this horizontal line is called as a x axis and this vertical line is called as a y axis. Okay, these two axes we have to consider because we have two things. One is time and one is distance. So on one axis we have to take time and one axis we have to take distance. Okay, now at one point these two lines are cross each other. This is the midpoint of this graph and this called as a origin of graph. What? Origin of graph. It has coordinate 0, 0. Means x coordinate 0 and y coordinate is also 0. Now what we have to do? We have to represent these two things. First is time and second is distance on x and y axis. Here we take time on x axis and distance in y axis. Now we know if you observe graph paper, then you will find there small squares of 1 centimeter by 1 centimeter. Look at that, such like that. Okay, on graph paper, such a squares are you observe. Okay, this is one, this is one. So such a squares are you observe. The length of that 1 centimeter and the breadth is also 1 centimeter. So on graph paper, you observe such a 1 centimeter by 1 centimeter squares. Okay, so this is nothing but the 1 centimeter. This is the one square, this is the another square. Okay, so such are the squares are present on this graph, and breadth and height of that square is how much? 1 centimeter. So on x-axis, look at that, these scales are very important. Okay, on the upper part of right hand side, when we are drawing graph, always we have to write scales, because that scale tells us what we actually do here and how can we draw this graph. Okay, so these scales tells us very important information. So always remember that whenever you draw a graph, then always you have to write the scales on upper side, right hand side of your graph. Okay, now here on x-axis, what we consider? Time. Okay, actually for 1 centimeter we have to consider first reading 10. For the second centimeter we have to consider second reading 20. So its meaning is that for x-axis 1 centimeter, what we consider on x-axis, that is the time. Okay, for 1 centimeter our first reading is how much? 10, that is in second. For x-axis 1 centimeter is equal to 10 seconds. Okay, what is represent this line? This line represents us on x-axis 1 centimeter is equal to 10 seconds. Similarly, on y-axis, this is our first reading on first centimeter. Okay, and on y-axis, what we represent? Distance. What? Distance. Okay, so here we represent distance. Okay, so on 1 centimeter is equal to 20 meter. How much meters? 20 meter. On y-axis 1 centimeter is equal to 20 meters. Okay, so these are the scale. First you have to give on right hand side upper part of your graph whenever you draw graph, because these are the very important part that tells us all the information whatever we draw on x and y axis. Again remember, we have to always write scale on our upper part right hand side of our graph. Okay, now we have to draw this graph of distance time for uniform motion. Okay, here on x axis time and on y axis our distance. So first reading we have to take at 0, 0. At a 0 time our distance is how much? 0. So here 0, 0. Okay, our time is 0 and our distance is also 0. Now second, after 10 seconds, okay, we are draw time on x-axis. Look at here, on 10 seconds, our distance is how much? 50 centimeters. So look at, here is 20, so below 20, somewhat where should be 15. Suppose here, our 15. So this is our first point. On 10 seconds, our distance will be 15 meters. Now second point, on 20 centimeter, our distance is how much? 30 meters. So on 20 seconds, our distance is how much? In below 20 and 30, somewhat here should be our 30. Suppose here is our this point. On 20 seconds, our distance is how much? 30 meter. Next is what? After 30 seconds, our distance is how much? 45 meters. So, after 30 seconds, how much? 45. So, it will be, here will be 50. So, in between 40 and 50, our 45 is somewhat here. Okay, so, this point should be somewhat here. Okay, then after 40 our distance is how much? 60. Look at 60 is here and 40 is here. Okay, so if you draw, then we will find this point is in between somewhat here. Next is after 50 seconds our distance is how much? 75. On 50 centimeter, on 50 seconds our distance is how much? 75. Here will be 70, in between 70 and 80. Suppose somewhat here will be our point. Okay, so here will be our point, that is the 50, 75. And last is after 60 our distance is how much? 90 centimeters. Okay, so in between 80 and 100 here is somewhat 90. Okay, after how much? 60. So here is the 60 our. So now we have draw all the points here. Okay, finally what we have to do, we have to join all these points. Okay, so actually it's not gonna straight line, but if you take a scale and draw this line, okay, that will be a straight line. Okay, what? That will be a straight line. So remember that what happens in uniform motion. Uniform motion means what? Simply equal distances are covered in equal interval of time. Then if you draw distance time graph, okay, at that time your graph will be straight line. What? Straight line. All point of graph will be in straight line. So remember, for the uniform motion, graph of distance and time is always in straight line. Okay, so whenever you draw graph, so this something you have to remember. I again tell you, that is, first is scale, this is the important part, and two things we have to draw. First of time and second is distance. So one axis, on x axis we take time, on y axis we take distances, and just we see after 10 seconds how much distance is covered. That point we plot, and finally we join all the points by straight line. It is a straight line because motion is uniform. From that we studied, for a uniform motion distance time graph is always straight line. Okay, what? For a distance time graph for a uniform motion is always straight line. Okay, so other graphs also we have to see. Okay, okay, so next graph we have to see, that is the distance time graph for non-uniform motion. Okay, first graph we see, that is the distance time graph for uniform motion. Now here what? Non-uniform motion. Okay, we already know non-uniform motion means what? Equal distance, unequal, equal time, unequal distance. Okay, if an object cover unequal distances in equal interval of time, then such a motion are called as a non-uniform motion. In first 5 seconds 7 meter distance is covered, then next 5 seconds only 5 meter distance is covered here. Okay, so this interval of distances are not equal, so this is what? Non-uniform motion. Now again same way we have to draw a graph that we already draw for uniform motion. On x-axis we represent time. Okay, 1 centimeter is equal to 5 seconds, and y-axis we represent distance, that is 1 centimeter is equal to 10 meter. Okay, so by using this data only we have to plot this point on the graph, and we have to see what happened here. Okay, on first 0 0, that is first point is here. Okay, second 5 7, on 5 seconds 7 means somewhat here. Okay, that point is should be somewhat here, that is our first point. Okay, then second 10 12, for 10 this is 10. Okay, this is suppose 12, so second point is somewhat here. 30 and 20 is here. Okay, so that point it should be here. Okay, now 20, 30, this is the 30. Okay, this is the 20. So our point is should be something here. Okay, then 25, 41. This is the 25, this is the 40. Is somewhat here. Suppose 41. Okay. For this 25, we have how much? 41 here. Okay. Then 30, we have 50. This is the 50. We have how much? 41. 50 for 30. This is 30. And this is our 50. Okay, so that point should be here. So now, if you draw here all the points, then we will see first point is here, second is here, third is here, fourth is here, second is here, fifth is here. Okay, so if we draw all that point with a straight line, that we will see that this all the point are not in a straight line. Okay, so what we already studied, for uniform motion there are we draw line that is straight line. Okay, but now for what happen here in the case of non-uniform motion, whatever the drop we draw here, that is not all the points are not in a one straight line. Okay, so that is the difference between uniform motion distance time graph and non-uniform motion distance time graph. Okay, what happen in case of uniform motion, all the points are in straight line, and in case of non-uniform motion all points are does not came in straight line. Okay, that you have to remember, and such a way that you have to draw this distance time graph in your notebook. Okay, you all have to draw these graphs. Okay, all the graphs given in our books, that you have to draw in your notebook. Okay, as a homework. Okay, that is a classwork, not homework, but as a classwork you have to draw this graph, because now we don't draw here right now, so that is why you draw it later on your notebooks. Okay, so next graph we have to see, that is velocity time graph for uniform velocity. Okay, up to now we have to see two graphs, uniform motion and non-uniform motion. Now we have to see velocity time graph for uniform velocity. Okay, now what is mean by uniform velocity? Simply uniform means what? Same. If an object travel a distance with same velocity, okay, if suppose I have to go from Shirur to Pune, okay, then if I start my bike with 50 km/h, okay, up to reach Pune, I not change my velocity. Okay, that is remain 50 km/h up to Pune. Then that motion simply is called as a, that my velocity is simply called as a what? Uniform velocity. Not a change takes place in my velocity. Uniform. Uniform means same. Throughout the motion, my velocity is same. Now here we have to consider one case. Okay. Here suppose the velocity of an object is constant, means same, that we call as a uniform velocity. Suppose we have to consider case in an object travel with uniform velocity of 60 km/h. 60 km/h. Okay. So look at, initially it has a velocity 60 km/h. On y-axis we represent 1 centimeter is equal to 10 kilometer per hour. Okay, so here 60 kilometer per hour, it will travel with uniform velocity of 60 kilometer per hour up to first hour 60 kilometer per hour. After second hour it is also 60 kilometer per hour. After third, fourth, fifth, sixth hour, velocity remains same. Velocity does not change throughout the motion. Okay, so such a velocity is called as a uniform velocity. When object travel with same velocity throughout the motion, that's called as a uniform velocity. Here what happened now, and this is a graph, okay, because we don't have other point. For first hour it is also 60 kilometer per hour, so our first point will be here. For second hour again it is 60 kilometer per hour. For a third hour 60 kilometer per hour. For a fourth hour also it is, and further all the time our point will be on this straight line start from the 60, because our velocity does not changes, it remains same 60 kilometer per hour throughout the motion. Okay, so such a way that we have to draw a graph, velocity time graph for uniform velocity, in which velocity remains same throughout the motion. Now another one question that asked in our book, how much distance will cover in between time second hour and fourth hour. Okay, so in that much time span, 2 hour to 4 hour, how much distance will be we cover. Okay, so simply we know what is the velocity of an object. Simply it is the 60 kilometer per hour constant. So simply if we look at this graph, then we will observe that from 2 hour to 3 hour. Okay, so this 1 hour span, how much distance it will cover, that is the 60 kilometer. Okay, plus in the next second hour, 3 hour to 2 hour, in this 1 hour, how much distance it will cover, again 60 kilometer. So in between 2 hour to 4 hour, how much distance we will cover, that is the 120 kilometer. Again one method to find out this distance, that is the area. Okay, so look at that, this second method is we have to find out area of this rectangle. Okay, area of this rectangle is nothing but the distance covered throughout this time span. We know this is a rectangle, and formula for the area of rectangle is area of rectangle. Okay, area of rectangle, it will be height. Okay, that is the h into this breadth, height into breadth. Okay, so height is how much? Height is our 60. How much is our height? 60. So height is how much? 60 into breadth is how much? 2 to 4. 4 minus 2 is how much? 2. So into 2, so it will be 120 kilometer. Okay, so such a way that this area is also give us distance cover in given particular time. From this common observation we can also find out this is 60 plus 60, 120 kilometer. This area is also give us distance between this our path. Okay, so that is also 120 kilometer. So such a way that we have to calculate we have to draw graphs. Okay, simply always remember, always you have to write this, what, this notations on here right side of the graph, that tells us information about the graph, okay, and such a way that on x and y axis we have to take variables and through which we have to draw graph. The remaining part of chapter we will see in next lecture. Thank you.